Now we have make mention of all this, so it is good for us since we have seen what oxidation and reduction is. An oxidizing agent, a reducing agent is. We have seen oxidation number, so we should see now how we can be able to calculate the oxidation number or the oxidation state in a part of an atom in a particular compound. Now when we look at it generally, we see that all non-metals, they have that tendency of gaining electrons, while all metals have that very high tendency of losing electrons. Then now we see that we always have special cases. Now for a neutral atom, that is an atom which is uncombined, its oxidation number is always 0. When an atom is uncombined, its oxidation number is always 0. Now for example, we can have something like chlorine gas. Its oxidation number is 0. It have not combined with another different atom. Oxygen gas, oxidation number is 0, not combined with another different atom. Sodium, existing in its natural state, oxidation number is 0, not combined with another atom. Then now we have another case like for oxygen. The oxidation number of oxygen in a compound or ion is usually -2, except in cases such as the peroxide. Except in cases such as the peroxide, we can have an oxidation number of -1. You see, we can have an oxidation number of -1, and in some other cases, we have some other cases, and also with fluorine. With fluorine, you see that the oxygen will have an oxidation number. I can have an oxidation number of +2 or of -2. The reason why with fluorine is always a different case is because that fluorine is extremely the most highest electronegative element, and for it combining with an atom, it will be very difficult for fluorine to lose electrons, so it will only gain. And fluorine combining with oxygen must donate the electrons to fluorine, and that is why you see oxygen have a positive oxidation number and not a negative oxidation number like +2 and +1 in the case of with fluorine, like in case of fluorine. Then now we have an oxidation number of hydrogen. The oxidation number of hydrogen is always +1 for non-metals. That should be now for covalent compounds, but with non-covalent compounds like ionic compounds, hydrogen will have an oxidation number of -1. Will have an oxidation number of -1. And now we look at generally when you see all Guban elements, the alkali metals, they have an oxidation number of +1, because they will have 1 electron in the outermost shell, and they have that great tendency of always losing the electrons. Then now you see in the case of like group 7 elements, they have that great tendency of gaining 1 electron. They have 7 electrons in the outermost shell, and the oxidation number, it is always found to be -1 in most compounds. So with this, we can be able to solve the oxidation state of some species in a particular compounds. Now for example, we can have for example let's say we'll calculate the oxidation state of phosphorus in the following. Let's say calculate the oxidation state of phosphorus in the following. The oxidation state of phosphorus in the following, we have 1 phosphorus hexaoxide. We'll have maybe the 2. We'll have a compound such as phosphorus. We have for example these two compounds. have a compound and an ion here. We want to calculate the oxidation state of phosphorus. The first thing for us is to let this phosphorus be equal to maybe a particular letter X or Y is oxidation state, because from when you look at it, you see that the sum of oxidation state of the different species in this compound must be equal to 0, since their overall oxidation state is 0. And for this compound, sum of oxidation state of the different species must be equal to -3. So we can say, since we don't know the oxidation state of phosphorus that we want to calculate for, we say let the oxidation state of phosphorus be X. So that if we have here, there are 4 of them, 4 times X plus there are 6 oxygen, 6, but in most compounds oxygen is always -2, should be equals to 0, since the overall oxidation state is 0. So that will imply that 4x minus 12 is equals to 0. And from here we can see that 4x should be equals to 12. When the 12 crosses the equal sign, it becomes positive. We can divide all through by 4, so that it will imply that x is equals to plus 3. X is equals to plus 3. So we can see that the oxidation state of phosphorus in this compound is plus 3. And bear in mind, the answers in this case are always given. The answers in this case are always given with a sign. A sign must be attached to the answer to tell us, because an oxidation number can either be positive or negative. Now let us go into the case of the second one. This is 1. This should be 2. So from here we can say that X, since there's only one phosphorus, they will have X plus there are 4 oxygen atoms. 4 times -2 should be equals to -3, since the overall oxidation state is -3. This will imply that X minus 8 should be equals to -3. You send -8 to that side to imply that X should be equals to -3 plus 8. And from here we imply that X is equals to plus 5. 8 minus 3 is equals to plus 5. So these are cases we have had the oxidation state of phosphorus in this compound and in this ion. Now we can have another case again. We can take some 2 other examples to make sure that the calculation of oxidation state becomes familiar. We can have let us say calculate the oxidation state of sulfur. The oxidation state of sulfur in the following. For example, we can have sulfuric acid. Let us say 2, we can have maybe sulfur trioxide, and let us say 3, you can have a sulfate ion. You can have a sulfate ion. Or let us say we have a sulfite ion. Let us take a sulfite ion. Now in these cases, what do we say again? We say let the oxidation state of sulfur be X. So in the first case we imply that since there are two hydrogen, for hydrogen is +1 in the covalent compound, so we have 2 times 1 plus sulfur is X plus X plus 4 times oxygen is -2 should be equals to 0. This will imply that 2 plus X minus 8 should be equals to 0. And from here we imply that X, you see here, -6 should be equals to 0. And from here we imply that this will imply that we are going to have X should be equals to plus 6. So this is the oxidation state of sulfur in this compound. In the second case, we have sulfur trioxide. We say so that there's one sulfur here, so that X plus 3 times oxygen is minus 2 should be equals to 0. This will imply that X minus 6 will be equals to 0, and from here will implies that X is equals to plus 6. Then we have the third case. So the third case, this is the second case, this is the first case. So we have the third case, sulfur 2 minus. So we say 1 sulfur X plus oxygen, there are 3 atoms of oxygen, times minus 2 should be equal to minus 2. This will imply that X minus 6 should be equals to minus 2. From here we imply that X should be equals to minus 2 plus 6. We imply that X should be equals to 4 plus 4, since 6 minus 2 is equals to plus 4. So these are the cases we have had, and we thank you very much for watching the videos on Turbo Charles Bisong's channel, and we plead on you that you should subscribe. And don't forget to come and watch the other video, because in the other video we'll be talking on balancing redox equation. We have balancing normal redox equations, balancing redox equations in acidic medium and in basic medium. So don't forget to come and watch those other videos. Don't forget to come and watch those other videos. It will be very interesting for you to partake here in watching those other videos. And thank you. May you subscribe onto this channel.